So greetings of the day. In earlier lectures for the subject operations research technique, we have seen in under unit 1 linear programming, and right now we are in unit 2 where we are dealing with the aspect of assignment and transportation model. In previous lecture we have solved entire number of problems pertaining to objective function minimization type of problem, where the task was to minimize the parameters, maybe cost of production, maybe cost of assignment, or maybe man hours needed to perform different tasks by different operators. We have seen how to attempt from formulation of the program, then formulation of related assignment matrix, and we have discussed Hungarian method for solving assignment problems. In Hungarian methods, which we have particularly seen for minimization problem, several steps were involved. So first we have ensured that the size of matrix was square matrix, followed by we perform row reduction referred as row operation, then column operation, column reduction, to bring 0 in each row and each column. And after ensuring that each row and each column has at least one 0, what we did is we have assigned those pure independent 0 cells and checked whether the solution which we got was optimal or not. So now I'll quickly go through one of the solved problems where you will be in a position to revise taught in earlier lecture, and you will be in line with today's lecture, because in today's lecture what we will be dealing with for assignment problem is we will be analyzing different types of assignment problems can be solved by the same method of as provided by a scientist called as Hungarian. In earlier method, if you recall, we have only focus our attention for minimization type of objective function with a square matrix, that is n by n or m by n matrix, wherein we were having equal number of rows and columns. So now we'll switch over to the problem just to recall what we have studied in earlier lecture, and then I will go to special cases of assignment problem. Now this problem reads as, a department of a company has 5 employees with 5 jobs. 5 employees, 5 jobs. Assignment, 1-to-1 assignment. The time in hours. Now this particular matrix is representing the time in hours that each man takes to perform each job in the form of effectiveness matrix. What is to be done? How the OR specialist will allocate these jobs to different employees so as to minimize the total man hours. So objective function is, now as we have studied in our earlier problem also, objective function is minimize. Here it is not cost, it is minimize total man hours which are given for different combinations of jobs and employees. So by permutation and combination you will get number of answers, but you are not sure which answer is the optimal one. So what we will be doing? will be going through standard Hungarian method, and that Hungarian method will end with one of the best optimal solution to this particular problem with proper assignment. Now the first, this is again revision, we have already solved complete problem pertaining to this structure. So this is 5 by 5 matrix, means it is square matrix, it is 5 by 5 matrix, 5 rows, 5 jobs and 5 employees, different employees. Our aim is to assign each one of these job A, B, C, D to the employees, available employees 1, 2, 3, 4, 5 in such a way that total man hours of performing these all 5 jobs through all 5 employees is minimum, that is the target, that is the objective function of this particular assignment problem. So if you recall, first step in assignment problem was to ensure that it is square matrix. So yes, it is square matrix, 5 by 5 matrix. Now under step number 1, 2, 3, 4, 5, 6, 7, we have seen 7 steps in our earlier lecture. So after ensuring that our size of matrix is n by n, we have to perform row operation. In some textbook they are also referring that as row reduction. How to perform that? From each row identify minimum value. So here you can see 5 is minimum. So what is to be done? Subtract 5 from all elements of the first row. 10 minus 5 is 5, 5 minus 5 is 0, 13 minus 5 is 8, 15 minus 5 is 10. So likewise for second it is minimum is 3, this is minimum 5. For third minimum is 2, so 2 is subtracted from all third equation. For fourth row minimum is 7. See, this minimum is at 2 places, nothing to worry. So 7 minus 7 will yield 0, 7 minus 7 will yield 0, and rest 11 minus 7, 4, like that. And for last row minimum is 4. So 7 minus 4 is 3, 9 minus 4 is 5, 10 minus 4 is 6, 4 minus 4 is 0, 12 minus 4 is 8. So this particular matrix is the result of step called as row operation. Now after doing row operation, what we have to check is whether all columns are having zeros. So first column is having 0, second column is having 0, third column is having 0, fourth is having 0, fifth is having 0. So no need to perform in this particular example column operation, because while doing row operation we can notice each column is also having at least 1 0, which is a prerequisite before we start assignment. And now if you recall, I have given you one hierarchy in earlier lecture. The hierarchy was stated by me as like this. If you recall, that this should be the order of assignment to single pure independent 0. First row followed by column. I have stated like this, that we will go for single pure independent 0 for all rows from top to bottom. If this is finished, then we will switch over to rows with, if rows and column both are finished for this condition, we will switch over to double 0 for rows and column, then one cut, one uncut 0 for rows and column. That I have already explained. If you follow this criteria, we see that we get the first assignment as A with 2, B with 1, C with 3, D is not getting any assignment and E with 4. Now we have seen that this is 5 by 5 matrix. We want to assign 5 jobs to 5 employees, but the initial solution which is available is representing only 4 assignments are done. One job is still not assigned, that job number named at D. So it is very sure that this is not optimal solution, since for 5 by 5 matrix I am only having 1, 2, 3, 4 assignment, where instead I should have 5 assignments. Now merely, I have repeated this particular in my earlier lecture, merely saying that since this is having 4 assignments for 5 by 5 matrix will not suffice the optimality test. So we have seen under step number 5 that to perform optimality test we have to draw the minimum number of lines which covers all zeros. All zeros means assigned zeros, uncut cut zeros, everything. So if the minimum number of lines covering all zeros are equal to size of matrix, then this particular solution would have been or is optimal. If I arbitrarily draw number of lines covering all zeros, like they see 1, 2, 3, 4, 5, and I say okay, 5 number of lines I have drawn, those lines are equal to size of matrix. One can claim like this. Other student can claim, okay, I will arbitrarily draw 1, 2, 3, 4, 5. All these 5 lines which I have drawn also covers the assigned and cut zeros. But this claim is false. Students, remember, this claim is false. What is the condition? Condition is that minimum number of lines covering all zeros. What we have to do? Minimum number of lines covering all zeros. This minimum word is important. If you go by stated procedure as we did in step number 5 in previous examples, and if those minimum number of lines are equal to size of matrix 5, we will say that the solution is optimal. So now in that step, if you recall, we have written that you have to tick mark, you have to start from the cell to which there is no assignment. So obviously we can see that row name D is having no assignment, so we will tick that particular row, and then we have to check in ticked row where there are zeros, and then we will be ticking those columns. So in next slide I will show how we proceeded for drawing minimum number of lines. So this is the step up to 4. You got 4 assignment. Now we'll go for next. See, this is the complete solved problem applying the same concept. Now this particular row was not having first assignment, so it was marked like this. So I will again do what I did earlier for your understanding. So this was the first mark. Then we have marked columns having 0 in mark row. So now, right now when I am explaining, focus your attention to this red color tick mark. This will help you in better understanding, revising what we have already studied in earlier lectures. And now once you did this particular case, what you have to do? You have to mark those rows having assignments in mark column. This is mark column. In this mark column, this is the row having assignment. So you have to mark this particular row. This already we have done in our earlier lectures. I am just repeating what we have done. Then for this particular column, here you are having assignment, so you tick mark this row, and then you know that what we did in our earlier lecture was draw lines through mark columns, draw lines through mark columns, and draw lines through unmarked rows. So I am repeating this, which I already solved. So now students, you can see here, this is 1, 2, 3, 4. Minimum number of lines, minimum number of lines are 4. So first see whether these 4 lines cover all 0 or is there any 0 which is not covered. So after checking, these 4 lines cover all zeros, which is less than size of matrix. And what is the size of matrix? 5 by 5, 5. And therefore this solution is not optimal, that we have seen. And now then next step was to move towards optimal solution. So what we will be doing? We will be moving to optimal solution. Under that, our step was, amongst these, identify the value which is minimum. So if you look to these values through which line does not pass, one is 6, 15, 3, then 5, 2, 4, 5, 6, 8. So what we have to do? We have to select first minimum value. So obviously you can see from this 5, 6, 15, 3, 4, 2, 5, 5, 6, 8, which is minimum. So minimum is 2, through which line does not pass. And now what we have studied? 3 steps. Subtract this minimum value, selected value, from the cells through which line does not pass. Like this 6 minus 2 will become 4. Can see? 6 minus 2 will become 4. 15 minus 2 will become 13. 3 minus 2 will become 1. Similarly, 4 minus 2 will become 2. 2 minus 2 will become 0. 5 minus 2 will become 3. First step. Second step, add this minimum value where there is intersection of 2 lines. So earlier the value was 5. 5 plus 2, 7. This was 10. Intersection of 2 lines. 10 plus 2, 12. Here it is 8. 8 plus 2, 10. Here it is 0. 0 plus 2, 2. And keep rest of the values through which line passes once, single time, same. So you get this matrix. Improved matrix. This is improved matrix. Improved matrix. We have seen this. Again, what I am repeatedly telling is, to end with assignment, we are refreshing what we have done earlier. So now we have to start again assignment. Assignment by the same logic. Go for first by rows, then columns with this concept, 00 concept, 1 0 1 cut 1 uncut 0 concept. And now if you see here, by this logic, this particular first column is representing. So if I allocate over here, there is no 0 to be cross off. So my first row is done. I have done with it. Now I will go from, for rows, I have explained in my earlier lecture, go from top to bottom. For column, go from left to right. So I did with first. Now what I will do is second row. This hierarchy I have to select. Yes, I got this. Cross off this. That is very essential because it is 1 to 1. Okay, I end with second. Now see here, in third row I am getting 2. I will not directly rush for row number C. Why? Because I will follow the hierarchy. Hierarchy says first assign in rows with single pure independent 0. Therefore I will omit this particular third row. I will go to this, again there are 2 rows. I will not go. Last row, yes, only single 0. So what I will do, I will assign over here and I will cross off this particular 0. Students, now I have done this with rows. I will check this single pure independent 0 with columns. So switch over to column. This column is having no 0 for assignment, no 0 for assignment, 2 zeros. But what the hierarchy says, column, once you finish rows with single 0, go for column with single 0. Here I am getting 2 zeros. I will not disturb this particular column first. I will try, is there any column with single pure independent 0 available for assignment. So I will switch to column number 4. There is no 0 to be assigned. I will switch to column number 5. If you observe the values in column number 5, yes, there is only single pure 0, and that is this 0. When I am assigning this 0 of the column, this corresponding related 0 will get crossed off. And now I know the only remaining 0 to be assigned in this matrix is this particular 0, and this indicates me that I have finished with assignment, 1 to 1 assignment for this 5 by 5 matrix. I got 1, 2, 3, 1, 2, 3, 4, 5 assignments. Each row 1 assignment, each column 1 assignment, which ensures it is 1 to 1 assignment, that is one related job to one related manpower facility. You can see we have not assigned any 2 job to a single man, neither we have assigned vice versa to a man with 2 job, or any man, any job to 2 different persons. The need is, assignment problem says, if you are assigning job A, you have to assign to only one person available from 5. And now what was our task? If you recall, the task was to find minimum man hours. Now what we have done in our earlier lectures was, we have summed up time values or cost values of the initial matrix. We have added those values, and that was our answer. So now we'll see. You just remember these assignments which I have shown how to perform. In next slide, it is ready-made available what we did over here, which will be concluding slide for this particular problem. So now students, you can see here this particular what we have done is shown over here. See here, it has ended with like this. So this was the assignment which I have shown in previous slide. So what your task is? Your task is to write jobs. Your task is to write employees. So A with 2, A with 2, B with 1, B with 1, C with 5, D with 3, E with 4. And what are these values? These values are original values from the given matrix, which indicates the man hours needed to perform those jobs by different set of operators. So from that matrix we have picked 5 which pertains to the combination of A2. We have picked up 3 which pertains to the combination of B1, like that, and sum up. This is the answer. Total 23. Since unit is written over here hours, there is no need to write again repeatedly 23 hours, because already mentioned that this particular assignment needs 23 man hours, which is the minimum one. Now we have find this from Hungarian method. You try any permutation combination, any method available throughout globe, by which you can find what is the best allocation which will give you minimum man hours needed to perform this task. Your answer will not be less than 23. The optimal answer is 23 man hours. So this is how conventionally we have seen how to solve assignment problem. This is a for better understanding. Now I will go for special cases of assignment problem. Just I will show you what are the changes required. So now you can see here a project consists of 4 jobs. These are the special cases. Now I will just give initial beginning to these particular problems. A project consists of 4 jobs for which 5 contractors submitted. Now 4 jobs and 5 contractors have submitted tenders. The tender amounts quoted in lakhs of rupees are given in the table. So this 10 means it is 10 lakhs, 24 means 24 lakhs, that is the meaning. Find out the assignment of these different jobs to the tenders, which will yield in minimizing the cost of project. And naturally we know that whenever we are talking of any project, the intention of the project manager is always to reduce cost of the project. So this is the task given. Now here you know that minimum requirement, first requirement for any assignment problem is it has to be a square matrix. That is, it has to be n by n matrix. So number of rows and number of columns must be same. So here we can see that contractors rows are 5 and jobs are 4. This is 5 by 4 matrix. So this is not sufficing the basic need for any assignment problem. So what we have to do? It is not also that for making this square you eliminate by yourself any one contractor. No, that is not the correct process. What you have to do? You have to add. It is very important. These are special cases of assignment problem. This variety is called as unbalanced assignment problem. Unbalanced. Earlier we were balanced or square matrix we were having. Here we can see that it is 5 by 4 non-square matrix. So first we have to balance it by adding the dummy row or dummy column as per the number of cases. There could be a problem where there are suppose 6 contractor and 4 jobs. In that case that matrix would have been 6 by 4 matrix. So to make 6 by 4 matrix, 6 by 6 matrix, what we need to do is we have to add 2 more columns, dummy columns. Right now for this case what I have to do is I have to add one dummy I have to add one dummy column, call it as A. And now since it is dummy, I know this job will not be in existence, but temporarily to solve this condition of degeneracy, I have to add this. So I know this is not in real existence. So naturally the cost for all these will be 0. So remember, when you get assignment problem in non-square matrix, depending on the situation, whichever is less, if number of rows are less, add dummy row. If number of columns are less, add dummy column, and put cell value in those dummy columns or rows which you are adding as 0. Case number 1. Got it? This is first case, how to solve. And now once we did this, you have to go for, now this has become 5 by 5 matrix. You know now you have to perform row operation, then you have to perform column operation. Now one thing very important, since I have added 0 in each row, when you are adding dummy column, remember important step, when you are adding dummy row, dummy column, when you are adding dummy column with 0 in each cell, there is no need to perform row operation. Only you need to perform now column operation. Instead, if you are adding vice versa, 0, 0 as a dummy row, so in that case column operation will not be required. You have to perform row operations for which you want to bring at least 1 0, and then apply the same process as we did for number of problems with minimization. This is one thing that I wanted to stress, that how to convert. Earlier this was 5 by 4 matrix. What we did, we have converted this 5 by 4 matrix into 5 by 5 matrix, and then we are going for these steps, conventional Hungarian method. Clear? Next is, this is the problem which we have solved. Now this is very important, till now what we have seen, that the matrix was a sort of ready-made matrix. Assignment matrix given was ready-made matrix, but now in this particular case what you can find is data is given. It's a real life situation where the data is available like this, and the owner wants to optimize the things through OR consultant, OR specialist. He is not interested in what should be the exact form of matrix. He gave his original data and asked the consultant that I want this to be optimized. So what the problem says here, students, if you read it, a solicitor firm employs typist. It is the problem related to typist on hourly piece rate basis for daily work. There are 5 typists, number of typists are 5, having different charges and speeds. According to understanding, only one job was given to each typist, and typist was paid to the full hour. So condition is that each typist will get only one job. How many jobs are there? 1, 2, 3, 4, 5. Total jobs available are how many? 5. How many typists? 1, 2, 3, 4, 5. So number of typists available are also 5. So now it is very clear that this is 5 by 5 matrix. It's very clear. No need to add dummy row or dummy column. But you have to construct appropriate matrix. What is given? That even the typist who works for fraction of hour, he will be paid for full hour. We know that 1 hour is equal to 60 minutes. And if that 1 hour fraction, suppose it is coming as 0.8 hours. So for 0.8 hour, he will be paid wages equivalent to 1 hour. If it is coming 2.1 hour, 2.1 hour will be treated as 3 hours. 4.5 hours will be treated as 5 hours. 3.8 hours will be treated as 4 hours. That is the understanding you should have while forming appropriate matrix. Now see here, the data is like this. It is the rate per hour by different typist. Typist A quote 5, B quote 6. So typist B is quoting higher rate than other. Lowest quote is by typist C, 3 rupees per hour he is charging. And depending on their ability, number of pages how they can type per hour are given. Though if you look here, speed of typing is much more for B and very less for C. So looking all this aspect, the problem demands assign these 5 typists to these 5 jobs in such a way that cost of doing this particular task of typing these jobs through these typists is least, that is minimum. How to proceed? It's very sure that 5 by 5 matrix will be 5 by 5. So what we will be doing first, we will be writing here, these are the typist row wise, typist A, typist B, typist C, typist D, typist E. And for this cost matrix, column wise, these stands jobs. This is cost matrix which indicates combination of different typists with different jobs. Jobs are P, Q, R, S, T. Now important, how you get this particular value, that I am stressing. And once you understand how you get this value, it is very easy to calculate out this value. This particular matrix is, cost matrix is calculated. This particular cost matrix has to be calculated how? See here, this is typist A. Focus your attention over here. Typist A. His speed is 12 pages per hour. Typist A speed is 12 pages per hour. If you consider number of pages to be typed 199 by typist A, so with a pace of 12 pages per hour, to type 199 pages, how much hours will be required? So what I have shown for you, your understanding is AP. This is AP sale value. This is how I have estimated. AP sale value is, as marked here, 199 number of pages, 12 is the rate. So this will give you me hours. This will give me hours. for typing job P by A. Now here, if you divide this 199 by 12, you will get in fraction, and it will come something 16 point some value, fraction value, which is to be rounded. He is paid for full hour. So fraction to be rounded 17. 17 into 5 is 85. So this multiplied by this product, this is yielding 75. Now complete this A row first. What you have to do now? For Q, 175, 175, second, 175 divided by 12. If you are getting fraction, round it into 5. Third, 145 divided by 12 into 5. This will change. Into 5 will remain constant. Divided by 12 will remain constant. Only this number of pages for different jobs will change. Got it? In this fashion, what you will get? In this fashion, you will get this entire matrix. Now here, students, this is conventional 5 by 5. This is conventional 5 by 5 cost matrix, where we have to assign this typist to jobs with objective function. Least means minimize. So we have to solve this for minimization. We have seen a lot of problems pertaining to this variety. How to solve minimization type of assignment problem, and the method you know, Hungarian method. So after that, what you have to do? Perform row reduction, perform column reduction if required, assignment, draw minimum number of lines covering all the rows, check whether it is equal to size of matrix. If yes, solution is optimal, that is reached. If not, move towards optimal solution by the steps as we have discussed in earlier cases. So this is again a typical case where as a OR consultant, our job is to convert given data in problem format. This was the data given by the person who is interested to find assignment. He is not aware of the concept of OR. We have to change it. This is one variety. Now this is where we will end with assignment problem. Till now what we have discussed, if you recall, we have discussed with only objective function of minimization. We are talking since last 4 lectures with aspect of minimization. Minimization of objective function, maybe cost, maybe hours required to perform the job, like that. But in real life, we see a lot of applications of assignment problem where the objective function is not assignment, is not minimization. The objective function is, in most of the cases, is maximization or to maximize. Simple example, maximize profit. Assignment problem can be framed in the category of maximize profit. How to do? How to proceed? Can you think? Yes, we can solve maximization type of assignment problem by the same method as we did all problems. First, you have to ensure that whether the matrix is square matrix. Now here the example says a marketing manager has 5 salesmen and 5 sales districts. Again 5. So size is square. It is 5 by 5 matrix. Considering the capabilities of salesman and nature of districts, the marketing manager estimates that sales per month in 100 of rupees. These values are given for sales in 100 of rupees. So this 32 is 3200, 38 is 3800, 4000 like that. What is asked? Find the assignment of salesman to the districts that will result in maximum of sales. Now students, whenever it is sales, so no organization, no manager will be interested to lower or minimize sales. Objective function with sales will always be maximize sales. Now looking at the values given in hundreds of rupees, you have to assign these salesmen to the districts in such a way that by proper assignment of these salesmen to the districts, sales is maximized. So this is a reverse category of assignment problem. Till now we have studied all problems with objective function minimize. Now this is the first case where we are coming with objective function maximize. This is the first case where we are coming with objective function maximize. So yes, we can solve this problem by the same Hungarian method. Only at the first step we have to make one change. If you recall, in case of linear programming, we have seen the steps for maximization type, and when it was minimization type of linear program, what we did is we have only changed objective function by multiplying it throughout that objective function by minus sign, and we have interpreted result in the form of minimization. Here same thing we'll do. What we'll do, we'll convert this maximization to minimization. We'll convert maximization problem to minimization problem. How? Simple, first step only. From given matrix, identify which is the largest value. So the values available are, in first row it is 40, in second row it is 40, in third row 41, and here. So students, you can see that the largest value is 41. Largest value. I am talking of conversion of maximization to minimization. What is the steps involved? What are the steps involved that we are studying? No doubt, it is 5 by 5 matrix with maximization. I am converting now this into minimization. Simple step, identify first the largest value and subtract, remember, subtract all values of the same matrix from this largest value. So here suppose this value is 32, 41 minus 32. In next, this will be written as 41 minus 32. It is equal to 9. So in minimization matrix I will write at 1 to 9. Here I will write 41 minus 38. So this is difference is 3. Likewise, you will do for all these. 41 minus 41 is 0, 41 minus 41 0. So value which is subtracted from the same value will yield 0, and remaining values will remain as it is. Got it? Here it will be 1. Here in next iteration, that I will be showing, here it will be 41, so gap of 13. Here it is 1. So remember these values. What are the values? 9, 3, 1, 13, 1. Similarly, we will change all these values. What is the steps I have mentioned? What are the steps? Subtract all values from highest value. Once you subtract this, means you have converted that value into corresponding minimization type of objective function. After that, perform normal row operation, column operation if required, assignment, and Hungarian method for finding minimum number of lines covering all zeros. So I will show you how exactly the matrix look like. See, once you do this is the original matrix, and recall these values. I have shown these values 9, 3, 1 in previous slide. Similarly, these are the change values, and now this is salesman versus districts 5 by 5 matrix. Perform row operation, perform column operation. पहले first row, second column, third assignment, and fourth check. Once you get optimal solution, you will get assignment at respective places. Suppose you get assignment over here. So while writing maximization answer, interpret your answer in original matrix. That is the need. So suppose I am saying if you get assignment like this in this cell, so when you are writing final answer, don't write 3. I am talking of final assignment matrix. So if this is the assignment for 1B, you will not be writing 3, you will be writing 38, which is original. That is the care you have to take. So students, this is where I have finished with assignment models. So this is the last variety which I wanted to show you, that maximize to minimize, convert as the method says, and then interpret your result in the form of original matrix. So here I am ending the topic related to assignment models, which is the important part of unit number 2. From next lecture, we will start with further part of unit 2, that is transportation model. So till you can try all the problems pertaining to assignment model, and in next lecture we will see how to solve transportation model. So here I am stopping today's lecture till practice your assignment problems.